Welcome to Power Utilities Inspections using drones and AI. This is a joint presentation between AltoMaxx and Buzz Solutions, and we'll go through a quick intro of both our companies, our relationships, and what our total solutions can bring. Myself, I'm Hyun Choi. I'm the Director of Program Development here at AltoMaxx. My role involves building programs internally at AltoMaxx for services consulting, as well as building drone programs for our enterprise customers and government organizations. From Buzz Solutions, we have Caitlin Albertoli and Vikat Chowdhury, who are the co-founders of Buzz Solutions. Caitlin, Vic, do you want to do a quick intro?
Sure. Thank you. Thank you so much, everyone, for being here. I'm Caitlin Albertoli, one of the two co-founders and CEO of Buzz Solutions. My background is in economics, finance, and sustainability, and we launched Buzz Solutions in 2017 from a Launchpad course at Stanford University, which is where Vic and I both met and collaborated, and we are excited to be working with AltoMaxx. We've been working with them for the past about 6 months, maybe a little bit over 6 months, and we're excited about our partnership. And Vic?
Great. Thank you, everyone, for being here. I'm Vic Chaudhary, one of the two co-founders and COO and CTO at Buzz. Again, my background has been in energy sector and AI machine learning sector. Very excited to be here. I want to highlight the amazing work we are doing with AltoMaxx, with utility projects and see where it goes, and kind of want to highlight that in this webinar. So excited to be here.
Thank you. So just do a quick intro of AltoMaxx. We specialize in drone program development, training, consulting, sales, and inspection services. We have offices across North America. We cross from all the way the easternmost of North America, from St. John's all the way west to British Columbia and Washington State. And we have customers and provide services across the world. We have projects outside of North America and few continents around the world as well. We are one of the leaders in unmanned aircraft systems, procedures, and operations, and we are currently ISO 21384-3 compliant, which is the Unmanned Aircraft Systems Operations Procedures. It's a new ISO standard, and we are looking to get officially certified, and as well as being able to offer certifications. We have multiple certifications for our service capabilities. We have a unique certification called DNVGL, which allows our procedures have been certified for use on offshore and marine environments for remote inspections. We have pilots who are certified by Transport Canada for advanced operations, as well as being flight reviewers. As well as we also have pilots who are FAA UAS pilots under Part 107. Our specialties range from critical infrastructure inspections, and partnered with Buzz Solutions, we offer the capability of AI, computer vision, and data analytics of the data that we capture, as well as having some unique specialty solutions and data collection capabilities, such as ground penetrating radar, bathymetry, as well as metal detection, magnetometers. And these are very unique and interesting solutions that we bring to the industry as well. And for our consulting and training, we offer specialized training based on the industry, the requirements, all the way from hardware, software, to regulatory compliance. In Canada, we work closely with the regulatory body Transport Canada. We have members who work with Transport Canada closely to develop the requirements for pilot knowledge for pilot certifications. There are future regulation changes that we're working on, such as beyond visual line of sight and different categories of drones for heavier weight categories. So we have a pulse on the future of regulations, as well as what the industry is. Okay. Now we'll get into some of the work that we do in the power utilities industry in the transmission, distribution, and generation infrastructure. We leverage the leading industrial drone platforms and using the leading sensors, we are able to get data safely, efficiently, and reliably, and at extremely high quality. And we'll demonstrate to you some of the way we do this and the technology that we currently deploy. The main drone platform that we use is from DJI. It is the Matrice 300 RTK, which has high IP45 rating. It can handle weather in terms of precipitation, dust ingress, as well as having the widest range of compatible sensors for various data collection. We also are partners with AVSS, who produce the PRS 300 parachutes, the safety systems for this platform. This enables us to fly over people and over critical infrastructure safely in Canada, as well as being able, and as this is an ASTM tested platform, this enables us to also apply for flights over people in the US as well. That definitely enables us to fly in urban environments as well as rural and remote areas when we're doing critical infrastructure inspections. The sensors that we deploy are capable of capturing a wide range of different data. We have the typical, the one that we use mostly is called the H20T quad sensor. It gives us a wide-angle camera together with a high-powered optical zoom, combined with a thermal sensor and a laser rangefinder. We also have the LiDAR capability, a newly released platform called the L1. It also comes with a 20-megapixel camera, which is able to capture visual data at the same time as LiDAR, enabling polarized LiDAR data, as well as basic photogrammetry. Our main photogrammetry platform is the P1, full-size, high-resolution camera, which we use for the 3D mapping, modeling, and photogrammetry. The CSM, circular scanning millimeter radar, is not a data capturing sensor, but it is an obstacle avoidance sensor. Using a 360-degree radar scanner, we are able to stay clear and detect power lines, tree branches, even small obstacles, and even at night, since it is radar-based and not visual or infrared-based as well. And this enables us to capture high-quality data and operate safely. Some of the future sensors that we have in the pipeline is for this industry is the UV Corona camera. We are currently discussing with multiple manufacturers to see which would be the best one to meet our customers' requirements, as well as having it integrated into our main drone platform. One of the things that enables us to do work in the power industry efficiently is our high standard of operating capabilities, our multi-crew SOPs that enable dual station operations, as well as our drone platform, which is dual control capable. This enables us to capture and do inspections of linear infrastructure efficiently and safely. And to be able to do inspections and capture data reliably and have repeatability, missions can be pre-planned and recorded, as well as we can do on-site live mission recording, which can be repeated, and the exact data and positions and data captures are recorded so that future inspections can be repeated quite easily, more efficiently, and with the same level of reliability. These sensors and our drone platforms allow us to do very efficient captures. We have capability to do automatic zoom and grid coverage, and captures very high resolution image from a safe distance, as well as with speed. And at the same time, having multiple sensor capable payloads, we're able to capture thermal and optical data together as well. And we will show you how some of these data captures look like subsequently. Okay. The efficiency of the grid zooming feature can be seen here, where we can have coverage of a very large substations or infrastructure and make data capture at a very high detail, very efficient. This can be done in a single capture, and from doing a capture like this from a few different angles, we can have detailed data collected of optical information for most of the details required for such a substation. Okay. As well, we also have the capabilities to create a 3D model or a virtual twin, which is we leverage both photogrammetry and LiDAR to do this. Photogrammetry can also be used to do post-inspections as well. The 3D model can be manipulated, as well as the original data used to collect that can be used for inspections as well. And the other capabilities is, once you have a virtual twin or a 3D model, we can also do detailed flight planning around this digital twin, so that we can plan inspection flights extremely safely and have multiple missions saved for efficient operations. Furthermore, for transmission distribution line vegetation management, we have the LiDAR capability, and the LiDAR data and analysis can provide very valuable and efficient information for vegetation management. The LiDAR platform that we use, the L1, is capable of what's called a 3 return, where that enables us to measure both the digital elevation as well as the digital surface models. And that enables calculation of vegetation height relative to the ground. And as you can see here, the real-time data of the LiDAR point cloud can be visualized during the flight as we capture it, to make sure that the data quality is good as well. And there's these LiDAR capabilities promise us quite an interesting possibilities. And one example is a case study that we're looking into and working with DJI to bring this, is an example of a LiDAR scan that enables us to look at the heights of the vegetation relative to the power lines, as well as extracting the actual elevation of the ground. And there are some third-party software that is currently being tested to analyze the vegetation and the tree type, which can also be very useful for planning for the future as well. Okay, so those are some of the data that we are able to capture, and I will now hand over to our partners, Buzz Solutions, who, together with our capability, provide a full data acquisition, analysis, reporting capability, and data management solution. Okay.
Thank you so much, Ken, for that great detailed presentation, and we're excited to be able to share a little bit more. Let me see if I can.
Let me close that. Okay.
Yeah, thank you. So just to start off by talking a little bit about who we are at Buzz Solutions. So we are Buzz Solutions, providing actionable insights and analytics for grid inspections. So we, as mentioned, launched in 2017. And at Buzz, we are an AI-first approach. Our entire goal is to be able to provide the fault detections, analytics, and actionable insights as a part of these inspections with all of this visual capture data, much of which is captured by drones, as we are working with AltoMaxx as a part of this drone capture and analytics. So at Buzz, what makes us unique is we spent the first 2 years really building out our algorithms to the highest degree of accuracy. We worked with multiple different data sources. We partnered with different organizations. We also worked with utility capture data, drone capture data, helicopter capture data, and trained our algorithms in those first 2 years before becoming commercially deployable in 2019. And in 2019, we became commercially deployable and started testing our solution out in the market, working with utilities directly, and then also with drone providers as well, who are capturing different types of data across transmission and distribution infrastructure. And so for us, that's where we were able to really test out and see how our algorithms were performing in the market, which we'll be able to delve into a little bit later. But one thing I do want to highlight about Buzz is, we have been recognized in multiple sources, such as Forbes 30 under 30. We're also recognized in Forbes for our offerings, and many of the other industry news outlets as well, for our highest level of accuracy and also our fault detections and AI capabilities. So we have continued to grow and scale commercially. We're a team now of 10, but we're actively growing in order to deliver our offerings to the power sector. So with that, we're excited to kind of delve more into what we're bringing to the market.
Great. Thank you, Caitlin, for that introduction. Really excited to be here. Again, as Caitlin described, we are Buzz Solutions, providing actionable insights, analytics for power line and power grid infrastructure, both transmission and distribution inspections. And we do that using our software, AI, and machine learning technologies. Now, talking first of all about data management, we are going to walk through the lifecycle of an automated inspection project. After the data has been captured in the field using drones, we are going to highlight the aspects of data management, data processing and analysis, results, and insights reporting, actions that can be taken, and at the end, where do we go from there? What's next after that? Data management is actually a critical piece for utility inspections. Drones capture data in the field is provided to utility data storage infrastructures, whether it be cloud storage or on-premise servers, private cloud. In order to maintain data integrity, secure API connectors can then be used to either bring that data into one single platform where data processing happens, or the data can be analyzed in utility infrastructures as well based on the access levels that are granted for this storage infrastructure that utility has. We can also provide option of drone providers to directly upload the data to our servers, where we can analyze, process, and report insights through our full Power AI software platform. Going ahead, after the data has been managed, we have worked with data integrity and compliance systems of utilities or other companies that are in this domain. We have brought the data into one single managed location and collected in a streamlined manner. AI-based processing for asset and asset anomaly detection can now take place. So a typical life cycle of our models include proprietary data sets from utilities and research institutes such as EPRI, along with specific guidelines for labeling various assets and faults in these data sets for creating a training data set. For instance, these guidelines can include what kind of insulator is present. Is it a glass insulator, polymer, or porcelain insulator? And beyond that is what degree of fault or degree of severity of fault is present on that insulator. Whether it is, if the insulator is broken, is it flashed, is it contaminated, or if it's healthy insulator. So all those guidelines are provided for us to build that, the training data set. We then use our proprietary machine learning algorithms to train on these data sets and extensively validate the results with real world and in-field examples. Once these models are validated, they are ready to be put in production and deployed as APIs, which are also then integrated with our software platform, as well as provided as standalone services to utilities and other companies that are interested in the AI machine learning portion of our fault detections. Additionally, we map all the assets in the field using our GIS tools, as you can see in these images over here. And these GIS tools map all the assets and asset anomalies that is relevant for asset tracking and prioritization of work efforts that require actions to be taken for maintenance and monitoring of the infrastructure. Finally, we assign severity metrics also to various kind of faults, as well as assign color schemas to them, so that work prioritization can happen for the end user. They can highlight which faults to go after, which are high priority faults, highly severe faults that needs to be taken care of. For example, in California, we see a lot of vegetation encroachment problems can happen near high voltage lines. So that's a high severity fault, and our customers and our users can easily prioritize which ones they can choose and go from there. Just to highlight our fault detection capabilities, which is our core technology offering. So Power AI is our artificial intelligence engine, computer vision, machine vision engine that does fault detection on various kind of transmission and distribution assets. As you can see, some of the examples over here include a list of faults that we have, a high volume of faults and assets that we detect. So anything ranging from healthy dampers to damaged dampers. Some of the examples are displayed over here. Various kind of insulators, whether it be porcelain, glass, polymer insulators. If they are flashed, broken, damaged, contaminated, we detect those with a high degree of accuracy. We detect any kind of structural faults, whether we are talking about faults on the steel structures, so corrosion, rusting on the steel structures, hardware damages, AMOR grips, clamps that are broken. We detect those also with our AI. And also, even for distribution lines, we're talking about low voltage lines or city lines. If there's wooden pole damages, including rot on the wooden pole, or if there's damages due to woodpecker holes, we detect those also with our AI and cross-arm damages. And lastly, as we're seeing with much more emphasis on vegetation management, our tools have built this capability to detect encroachment or close proximity of vegetation to various assets or structures or poles. As you can see, there's one example over here. There's a vegetation growing very close to the lines. We flag instances as part of a mitigation effort, so that the users can go in and check where these kind of problems are happening and what kind of mitigation steps could be taken. We continue to refine our vegetation management efforts and algorithms with incoming data from either LiDAR, as AltoMaxx is capturing a lot of LiDAR data with sensors, but also with satellite imagery. So doing a first pass filter with line mapping and vegetation mapping around these lines using satellite, and then going in depth with LiDAR and seeing the actual absolute distances of vegetation and shrubs and trees, branches around these power lines. Another thing that we are looking at is using hyperspectral imagery to basically predict and forecast how this vegetation is growing based on standards such as NDVI, which is near infrared hyperspectral imagery used to create an index for basically seeing the growth of vegetation. That is of prime importance as we kind of forecast in the future that how the vegetation is going to grow around these lines, so that preventative efforts can be taken from utilities to actually manage their vegetation around the lines. So going ahead, we have now processed all this data. We have managed the data in one place, processed it. Now, what do we do with all these insights and results? So that's where we want to create, actions. That's where we want to leverage these insights and not let them sit in one location and nothing happen to them. We want to translate these results, these actionable insights, into something that is critical to the real world problems and can be used to mitigate the problems that are happening on the lines. So basically, we provide analytics, dynamic analytics dashboards where the user or the utility can go in and nail down on various kind of faults, look at various assets in the field, structure poles, transmission towers, and see what kind of problems are happening on those. But can also then export out those results in the form of CSV, JSON, PDF file formats, inspection reports, and even KML files that are used for GIS mapping. They can export all of that out using our API connectors. And these API connectors can then easily integrate. So we have built provisions for integration with work order management systems and GIS geospatial systems. So work order management systems like IBM Maximal, SAP, those kind of systems, and GIS systems such as Esri, ArcGIS. We are partners with Esri also. So we can easily integrate those insights and results for utilities into their existing platforms, applications, and systems so that they can take some actions. Right now, all these actions are, after the results have been compiled, these actions are critical and are done through manual API calls. But where do we want to go from here is automate that. Let's say, for example, when a fault has been detected on structures, there is an inspection project, various structures are analyzed, there's results generated, various faults highlighted. Where we are going is automating the ticket creation aspect of it. We integrate with the work order management system. Let's say IBM Maximo, we want to automate a ticket so that the user can at the end go and check the ticket and go out in the field and do maintenance and monitoring of the line if required. So the next portion is, where do we go from here? We are collecting so much historical data around power lines, visual data, and metadata around these assets. Metadata including geolocations, timestamps, so ranging from spatial as well as temporal features of these assets. So what do we do with that? The only piece that comes to mind is with more data, you can build more models. With more models, you can predict what's going to happen in the future. And that's the premise of our predictive asset management system. Since we're capturing more and more data from different regions, spanning spatially and temporally, we are also trying to bring in weather and climate data. So granular weather data affecting the regions where these assets are located, but also line data. So what's the rating of the line? What's the current rating, voltage rating, phase differences, those kind of inline sensor data we're trying to bring and kind of paint a full picture over here. So what's happening outside the line, what are the environmental factors, and what's happening inside the line, how much is there strain and stress inside the line. So we're trying to bring in all these factors and feed it to a machine, which is our predictive analytics insight engine. Is basically a bunch of algorithms acting as models, and they look at patterns in these historical data sets. So last year, an example of a pattern is last year we saw that in a certain location, there were 8 insulators that were damaged due to X, Y, and Z factors. Could include humidity or dry conditions, or higher heat, could include a lot of strain on the line over there in that portion of the area. So all these confounding factors contribute to something happening physically on the infrastructure. And we want to map that, we want to monitor that. So all these patterns are analyzed by our predictive models. And at the end, the predictive models output results such as probabilistic numbers or probabilities or statistical likelihoods of the health of a line or a health of an asset. Basically, the machine has seen in the last 1 year that in certain region 8 insulators have gone down due to X, Y, and Z factors. Now we are forecasting with an 85% likelihood that 6 insulators are going to go down in the next 7 months because of X, Y, and Z confounding factors. And that's the output of this predictive asset management system, and that can translate directly to it becoming to a predictive condition-based maintenance system. Now that you have a forecast, now you have an idea where things can go wrong. Utilities or customers can easily pre-schedule their maintenance crews in advance and have hotspot areas already assigned where problems can happen, because historically they have been happening a lot. So they have a much better insight into their health of the line and health of the asset and the region where these lines are located. And they're not flying their vehicles, either drones, helicopters, blindly. They have regions where they can nail down, and hotspot regions where they can go and inspect in detail. And that kind of takes this industry from being reactive to the problems to being more proactive and predictive in its approach. So that was a little bit of where we are going. Now we want to talk about what's happening behind the hood of these algorithms, these machine vision algorithms, and how they are improving. How is AI learning is the key portion. So we want to highlight the feature that we have developed. It's called Human in the Loop. It's a human-centered feature where we want to take into account subject matter experts that are in the field, whether it be linemen, field technicians, engineers. Since we are providing AI predictions, so the first piece of that is we give access to a software platform. Our AI models generate outputs, bunch of predictions, labels on images, whether it be insulator damage, conductor damages, dampers damage. Those are presented to at the start to the users, and these users can be subject matter experts or can be people who have been working on these inspection projects and have a guideline or a taxonomy of what their assets are supposed to look like. And they go in and they confirm or reject or edit or add labels that were either wrong, that were either missing, or that were editable. So basically, they have the capability of, let's say, add a new label. Let's say our machines don't detect damages on transformers. They can build like a bounding box. They can visually create a label right there and assign it on an image. Or they can even delete a predictive label if they think that's wrong. If it's if the machine says it's connectors that are corroded and they're not really corroded, they can easily delete that. And the great thing is all this information is then sent back to our backend systems. And what happens in the backend system is kind of a reinforcement learning for the machine or the AI. What that means is when the AI or the machine is wrong, it gets penalized, and when it's right, it gets rewarded. So in that way, the machine starts learning pretty fast based on user feedback, and this user feedback is critical for the accuracy of the model and the efficiency of the model to increase a lot, but also become much more personalized towards the data of the customer, basically. So we are seeing this happen in other industries also. Human-centered piece is relevant as we start off adoption of AI, and then it ramps up. So we start off with the premise of semi-automated approach where the humans are still involved and they guide the AI. So basically crawl, walk, and run approach. We are at the crawl stage, then the humans guided the AI to become much more personalized towards its data, much more stronger. That's where we go to the walk and running stage, and at the end, and we see a ramp up within a couple of months, even less than that, based on user feedback. And the AI becomes much more stronger. It learns pretty fast, and then becomes much more personalized. So again, increased efficiency for the human expert working with the AI systems. Which what that means is as AI becomes stronger, less and less amount of labeling or annotation or fault creation has to be done by the human, but also increased efficiency in AI systems leveraging human expert at the start of this life cycle or AI adoption. And those go hand in hand, and we see a ramp up exponentially with AI systems becoming much more smarter, much more robust, and much more personalized. And then increase efficiency with easier share of data and insights across the teams. As the AI becomes stronger, teams gain more understanding, more confidence in the AI, and they can take some actions on it. And then lastly, increase ability to capture human subject expertise in a single learning system, which is our whole life cycle of the human in the loop system that captures the essence of human and machine working together, and then humans guiding machine to a certain task where machine takes over. But at the end of the day, humans will always be part of the AI adoption piece. It's just a matter of what kind of work they do that might change, but mundane, repetitive tasks starting off will help humans that their efficiency decreases with repetitive tasks. And that's where AI can act as a tool. It's basically a tool in your toolbox that can help you achieve better results in your operations and projects. So how are we doing this human in the loop and a concept called active learning at Buzz? So when this flowchart is describing what is active learning. So we have our Buzz platform, which is our Power AI platform that has all the capabilities that we're providing for visual data management, AI processing, analytics, reporting, all those kind of features that I highlighted before. And once the AI does any predictions, labels are highlighted on our platform. Human in the loop feature kicks in. Again, we have enabled that feature in the platform where the user, feedback is used and contained and fed to the system, to our backend system. So all this feedback again goes to our backend system where continuously models are retrained. They are again reinforced, rewarded when they're right, penalized when they're wrong, and all these results from the model retraining are validated on our backend side of things. So we are continuously validating it with field results, with in-field data examples, and deploying them on our final product. And this closed loop goes back and then integrates with our Buzz AI and our AI APIs and Power AI software platform. And this is a closed loop basically over here, which is life cycle, which is predictions are done, user feedback is collected, it is used to train the model, retrain the model again, and then the models are deployed. And it's a continuous cycle, and we start seeing exponential increase in the model efficiency and accuracy and personalization. And that whole system is called active learning, which is, we can call it active learning, online learning, which takes into account user feedback heavily to make the models more robust, personalized, and stronger. In the images, there is, an example that we have on our software platform, as you can see, is a visual feature where, the user can go in, they can draw boxes or polygons on various kind of assets, or as you can see, some over here are quarter pins and assign labels, update labels, add labels, delete labels, and then all that information goes back to our systems to retrain, as I highlighted before, refine the models and make them more efficient and personalized. So at the end of the day, personalization and learning is the key portion for our AI systems, and that separates us from a lot of players in the market.
Thanks, Vic, for sharing all of that great detail and information. So now we just wanted to transition a little bit to talking about the value add of AI as a whole, but not only the value add of AI today, but also where we're going and the potential value that AI can bring with large scale adoptions. So of course, one of the first things we want to highlight is the cost savings. So direct cost savings are a major portion of the value of AI. Specifically right now, we're seeing about 50% on average cost savings as compared to this manual analysis, meaning compared to the humans that actually are spending all of these hours manually analyzing, tagging all of this data. We're seeing about 50% direct cost savings on a per image or a per structure basis compared to that manual analysis. We're also seeing incredible time savings. That is the second big value. As we highlight at Buzz Solutions, our aim is to save about 6 to 7 months compared to this manual analysis time, or the man hours needed to actually analyze all of this data. One example that I really want to highlight kind of throughout these different value adds of AI is a current customer that we have where they have a team of about 200 linemen and field technicians who are manually stitching together all of this data, looking for any visible faults and analyzing that by hand. They're actually taking about 8 to 9 hours every single day analyzing all of this data. That is an incredibly limiting factor for the scalability on the drone inspection side of things, because as more inspections are conducted, they need more engineers to be able to meet that demand of the number of images that are being captured. If not, there's a continuous lag time that we're seeing. And oftentimes the lag time is really what creates the biggest risk associated with any types of failed grid infrastructure, because by the time the images are analyzed, there is a potential for a line to have gone down, for components to have become more damaged, or for this imagery that's been captured to become outdated. And so that's where we see not only is there this direct cost savings and time savings, but also this indirect cost savings as well, and any types of risks that could be mitigated by early detection of some of these major faults. And we see that this is about 50 to 60% cost savings now, or about 6 to 8 months of time savings now. But we do anticipate that this is going to increase as AI becomes more accurate, as there's less need for human intervention on every single image, and also as more data is captured. And then that brings me into the third point of the scalability of this solution. So as there's more images that are captured, the AI actually becomes stronger, and we're able to put more processing power behind each of the behind the AI in order to process this data in a streamlined, efficient manner to scale with the number of images you're capturing on a daily, weekly, monthly, or annual basis. And we see that the accuracy continues to improve as the AI sees more and more data, more consistent data, as there's more human tagging of these specific labels. So we see that there's an even greater value over time as AI continues to scale and the accuracy continues to improve. And then that brings us into, okay, well, what can be done with AI? As Vic was mentioning, actionable insights and predictive analytics are exactly where we're going. So we're plugging in, taking all of this data that's been captured, using AI to be the central brain to analyze all of this information and provide these actionable insights that then can be taken to the work order management systems or plugged directly in there to generate maintenance tickets for any of the highest severity faults that are occurring on the grid. And then also predictive analytics. We see that the value of AI as we're continuing to track all of this historical data is these predictive insights that we're going to be able to generate. Not only will that provide even greater efficiency as we're looking at maintenance, but also it can help with planning for purchasing of equipment over the next year, 2 years, 3 years, 5 years, or also predictive vegetation management. And so we see that that also can tie back into this cost savings and time savings as we're optimizing the maintenance path over time. So with AI, I just want to highlight that we are already seeing a lot of these key benefits and values right now, but we do expect that over the next year, 2 years, 5 years, as more utilities are implementing drones plus AI on a large scale basis, that we'll just continue to see even greater value. And so that brings me into where Buzz is at today. So currently we're seeing on average that we are saving about 50% of costs compared to that manual analysis. But we've even done some pilot projects with utilities where we're saving closer to 70 or 80% of cost savings, which is very exciting for us. That's saying that, we're saving about 70% compared to what they're doing on this manual analysis, while also providing much faster results to that utility so that they can go and in turn and kind of translate to maintenance. And what I want to highlight here is our purpose is not to replace jobs. It's to use AI as a tool to be able to streamline these processes, to streamline this repetitive motion, repetitive nature of actually analyzing these images to create a more optimized path forward for more efficient maintenance. And that ties us into the 6 to 8 months of man hours that it takes. So we compare this to the man hours that it takes to actually analyze all of this data. As we're looking at more utilities starting to scale up their drone inspections and start to adopt large-scale AI, we're seeing that over the large number of images that there's actually a decreased efficiency with the human who's not able to label to the same level of accuracy and efficiency as they were maybe in the first 100 images as they're getting to 10,000 plus images. And so that's where we're seeing the time savings with AI continues to increase over time as compared to the human efficiency, which decreases over time. So we expect that this is going to continue to improve as well. And then the last point I want to touch on is also the savings that we're providing with our predictive analytics. Right now, we're looking at on average between $3 to $6 million saved per year in outage prediction. But we also see that these value savings essentially are going to increase as we're looking at things like vegetation management too, and as we're able to input additional types of sensors, and different types of data as well. But right now, we're saving on average $3 to $6 million on outage prediction, leveraging our predictive asset management system. So these are just some of the values that we're seeing right now with Buzz and also with AI as a whole, but we're really excited to see where this market is able to kind of transform as utilities are large scale adopting some of more of these drone programs and also large scale AI. So I just wanted to end there and thank you for kind of listening to more about our offerings at Buzz.
Great. Thank you, Vic. Thank you, Caitlin. And thank you, everyone online. We have, for those that joined later, if you could complete the survey just to give your feedback. And as well, just having both AltoMaxx and Buzz working together, and that really completes the loop from data acquisition to data analysis. And by bringing AI and big data into this field, there's a lot more that you can do rather than beyond actually saving time. You can be more efficient. You can do inspections more often. You can collect a lot more data than you were previously able to analyze. and that gives you better predictions, increases the overall safety, and makes the maintenance and predictive maintenance work more efficient as well. So, and working for data acquisition being closely tied to data analytics and AI, we also get the feedback of collecting good quality data and both learning what is a good input as well as what makes the AI more efficient as well. So in completing that loop from acquisition to analysis to predictive knowledge, I think our partnership is really going to bring great efficiencies and improvement to overall safety for the industry. Let's see if you have any questions. Let's see, I think Vic, you have answered some of these questions.
Yeah, there was. I think there was a question about false positives. So.
Yeah, false positives. Now, of course, I think AI will get better with by learning from more data that's being collected, and data collection efficiency and accuracy is greatly increased by the utilization of drones. And I think in the beginning, we would prefer to skew to the false positive and have the human in the loop be able to provide feedback rather than having false negatives where we miss any potential problems.
Exactly.
And do you have any AI tailored to hydro assets? Juan, as in, if you mean hydro, are you talking about generation side? Okay, yes. Vic, Caitlin, do you have any plans on hydroelectric generation assets?
Yeah, so our AI is currently not serving hydro. It's mostly for transmission distribution assets on the power sector. But given we have the capability, we have the systems that are already deployed in production that can work with different data sets also. So given given the right data set, given the right taxonomy and guidelines on what is a kind of an anomaly on the fault on the hydro assets, we can build a system like that, but that will be on a use by use basis. Again, we currently don't have a model that is already deployed.
So Dexter, I'll perhaps answer your question on what role do image capture specifications have in assisting AI predictions. Of course, the quality of the data matters. So the better we are able to capture details, then the AI will be able to predict it as well. Such as we had, for example, a lot of detailed cable details, which what we've seen wasn't able to be captured from ground-based capture or from a distance. Now we can get it from a drone at a much higher resolutions. And can images be consistently captured from human-operated drones? So this was something that we had covered in our presentation, which is we are actually able to record even the human operations so that it can be repeatable and reliable. So every action in terms of flight path, data capture, that can all be recorded for repeatability and reliability. So that again, for better prediction, we would need to have data captured from in the same format, same frame, from same location, and that would make it also assist AI to be more predictable as well. And
yeah, I think.
Yes, go ahead.
I was just going to add. Sorry to interrupt. I think the key over here for assisted AI, which Dexter is asking, is is kind of bringing like a homogeneous process in the industry to capture data so that AI can work at the the optimal level. If the drone captured specifications are homogeneous across the industry, that will be a big win in this industry for inspection processes.
Right. And by working in partnership with Buzz, from the data acquisition point of view, we could have a positive feedback loop where if we see that as a certain way of certain visual data input that the AI is, which is better for the AI, then that is something that we can implement into our data acquisition practices. And that as you know, these are all, we are currently consistently learning and improving. So these can all be put into standards and be updated even for data capture as well as data analysis. Bruce, is data different in North America operations versus other locations? In terms of the type of data, of course, there's optical, thermal, corona camera, and as such, but there are variations in the type of infrastructure, such as insulator types, the tower design, but fundamentally, there is not a large difference. And if we're able to collect specifications and a data set, then the AI can be trained to recognize different types of assets.
Yeah, I would say across North America, it's there's not a lot of difference. Yes, we do see certain shapes of insulators different, but in the European grid and South American grids, we see a much more difference over there from the data. But as Hyun, you said, with the right data capture and specifications, we can easily, kind of retrain the models again. And that's a great approach over there, which is called transfer learning. So the model already has an idea on what the grid looks like, but now it can also detect multiple designs of, let's say, insulators, which is a much faster learning process than starting from scratch. And that's the gain of this process called transfer learning, which is relevant over here.
Yeah, for Buzz specifically, that's why we started out with just looking at the North American grid so that we could provide the highest level of accuracy across all of the major faults and failure modes for the North American grid. But we do expect to expand beyond that to European grid, South America, and kind of beyond that. But as Vic mentioned, it's the process of getting the right data sets and also leveraging transfer learning to do that.
So I think there is another question.
Andres, yes, that is one capability that we leverage, which is the DJI Pilot App. Currently, with the 300 platform, you are able to record your live mission using waypoints, which also records your data capture actions. But we also leverage other flight planning apps as well. And for different types of data captures, we have different flight planning apps, as well as for capturing data that is very close to the ground. We also use special sensors to keep consistent altitude relative to the ground as well, beyond the GPS and altimeter capabilities. So the DJI Pilot App is part of it, but there are others. All right. And I think that takes us to, I don't see any more questions coming in, and I think we're right on time, and our hour is up. I thank everyone very much for attending, And I hope that if you have any further questions, please feel free to contact us by email or through our contacts. And but this webinar will be the recording of this webinar will be sent to all the attendees and also posted through our social media channels. So thank you very much again. And thank you, Vic, and thank you, Caitlin, for your insight and presentation on the Buzz AI platform.
Yeah, thank you so much. Thank you, everyone, for attending. It was a great time.
Thank you.
Have a good day, everyone. Thank you.